Okay, so yes, we have done this already. We will hopefully solidify what we have learned with this. Some of us might not be on the same level as others when it comes to factoring. So I kind of want to get us all on that same level of, okay, I know what I'm doing. You can throw any factoring problem at me. I'll knock it out and be done with it, okay? So if you're somebody that's already like factoring is my jam, I know how to do this, I don't need any help kind of thing, I apologize, today will be a little boring for you, but please just work through those examples, okay? So we'll get to this part tomorrow. Okay. Greatest common factor. Okay, the GCF. This is what you will like to see if I press unfreeze. Greatest common factor. The GCF is the greatest number or variable that goes into every term of the expression or equation or anything like that, okay? So it's the greatest number that goes into all the numbers, and then the greatest amount of variables that goes into all of them. These are also the problems you miss. Why? Because it's just not like the others. Okay, we get so used to factoring, we get so used to completing the square, we get so used to all the other ones that we forget about these smaller problems and we're like, I don't even know where to begin. Okay? The rule with greatest common factor is always, you're going to ask yourself that every single factoring problem you do. Is there a greatest common factor I can take out? If not, move on. If there is, it can make your life a whole lot easier. Okay? So in the first example, there is a 3 that can go in both 3 and 6. And an x, they both share at least one x, so I take out a 3x. Same thing here, 18 goes into both 18 and 36, and they both have at least 3 x's, and I can take those out. So what we're doing is we're undoing the distributive property. So if we're undoing the distributive property, we're dividing, technically, because distributing means multiplying, all right? So, greatest common factor. So go ahead and find the greatest common factor, and then factor it out of those two. It's got my greatest common factor of the first one. Yeah, Jenna?
4 to the third.
4x to the third. Okay. 4 goes into 8, 4, and 4. X cubed, they all have at least 3 x's, so I can take that out. So then 4 divided by 4 gets me 1, but then x to the 5th, I'm left with 2 x's. Then I have minus 2x, and then what? minus 1. Do not forget that placeholder. Because if we are undoing the distributed property, I should be able to look at it and I should be able to distribute all the way back through. And if I didn't have the negative 1 there, I would have nothing to distribute a 4x cubed to. So make sure you put that 1 there. Okay. What about the next one? What's my greatest common factor? Yeah?
3x squared.
3x squared. So they all have at least 2 x's, and they're all divisible by 3. Here we go. I get 2x cubed minus 5x squared minus 7x plus 9. Okay. So then the question always becomes, so if I can factor x squared minus 2x minus 1 further, then I would do that. Well, there aren't any factors of negative 1 that give me negative 2. Okay. But, and then down here, I can't factor that either. But you always want to double check if you can factor something further. All right. Trust me when I say this, I only got 2 questions during my 7 a.m. class, and it was over problems like this. And it wasn't that they didn't know what to do, like they didn't know what it was. It was just they factored out the greatest common factor, and they're like, what do you want me to do now? Like, that's it. You factored. That's it. Okay. So it catches up with you a little bit. All right, go ahead and try these 2. All right, what's my GCF for the first one? Who's got it? Someone that hasn't told me yet. Yeah.
6x squared.
6x squared. All right, when we take that away, we are left with 6x squared minus 7. So then the beauty of this is that maybe I didn't know it was 6. Maybe I knew it was at least 2 that came out. Okay? Once you divide it by 2, if you look inside the parentheses and say, well, wait a second, there's another number that goes in there, and it would have been 3. Okay, you can keep going if you can't find the greatest. All right? But yes, please keep going if you can. Okay? What about the next one? I thought you ran into it.
He just ran forehead into the door.
I was trying to break it down, Dane. Okay.
Kind of break it down. You actually did just kick in the door. Like,
Well, you couldn't kick it in.
what you did.
I would be
The
Superman.
door swings this way.
It's a feat.
Nah. Okay, greatest common factor, the last one there.
Entire wall comes down.
Jane, go ahead and tell me, what is it?
I think it's x squared.
Okay, no number?
No.
That's
I
weird.
mean 1x squared.
All the problems we've been doing have a number then.
Well, yeah, but I know you, and I think that you did this on purpose.
Do you know me?
I mean, I do know you because you're here and I've talked to you before, so technically speaking, I do know who you are.
Okay, cool.
Stupid.
But do you really know me?
I mean, I only know the people that they tell me they are, so I know who you tell me you are.
So I can just pretend.
Yes.
Okay, cool. All right, so yes, I can only take out x squared. I can't take out a number, and if it cannot be taken out, don't force it. Okay, don't make fractions happen, especially with greatest common factor. So 5x or 15x minus 20 plus 12x squared. And if you want to write that in standard form where it says 12x squared plus 15x minus 20, that would be preferred. But again, we're just taking out the greatest common factor. Okay? Again, between these and solving by square roots, these are the ones y'all miss because you're so used to the repetition of everything else. Okay, so don't forget about these. All right, so we've only done about 100 of these. That's a lie. We've done like 20. So this would have been the old way I would have taught y'all. I teach my CP kids and my, when I used to teach Algebra 1, I taught them one way of factoring and one way only. So if you're that type of person where you're already looking at this list and you're saying, that's a lot of stuff to remember. If you teach me one way to do everything and I know it works every single time, then I'm good with that, okay? So we did a bunch of these already, where we said factors of 18 that get me 9. And we jumped to the shortcut of saying 6 and 3. And we were done, okay? Shortcuts are great, but don't forget about there are longer ways to do things, and that's what we're going to be learning today as well. The difference between today versus what you'll do tomorrow. So this is today, and tomorrow you set them equal to 0 and solve. So today is technically, hey, can I factor? Tomorrow is, hey, can I solve by factoring? Which is the same thing, except you set them equal to 0. It's really just a way for me to get away with having 2 days of this to make sure we know what we're doing. Okay. All right. Now we don't need to do that one. Okay. So let's look at a case where my leading coefficient is not 1, and I can't factor out a number out of everything to make it 1. Okay. These are the ones you might have forgotten about. Okay. And that's what we're going to learn today, just in case you don't remember. So some people will fall victim to saying, well, I can't find factors of 4, they get me 8. Can't factor it. Let's move on. Okay? Not the case. Some of us might know, hey, I know I at least multiply 3 times 4, and I get 12. And factors of that, they get me 8. Okay, 6 and 2. Great. X plus 6, X plus 2. I'm done. No. Okay? Because as soon as you multiply your x's together, you don't get 3x squared. So please, 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 even though the shortcut is nice, don't fall victim to using it every time. Okay? So when we find our 2 factors, like we said, 6 and 2, we're going to use those to bust apart the middle piece, okay? The 3x squared, it does not matter which one you put first. Okay? Does not matter which one you put first. Now, me personally, I don't put parentheses. I put just lines underneath them. so it doesn't get confusing. People a lot of times that will put parentheses will think, okay, I'm done, I factored, because in factoring, your answer is 2 sets of parentheses. Okay. Greatest common factor between 3x squared and 6x. 3x. When I take that out, I'm only left with an x plus 2. Greatest common factor between 2x and 4? 2. And I'm left with x plus 2. Now, normally, I would just say, hey, what do you see double of? What do you see 2 of? X plus 2. And then I would say, okay, what's left when you take those away? 3x plus 2, okay? But we have the capacity to actually understand what's happening there. So in this problem up here, I'm able to say, what's my greatest common factor? And I said 3x, and I factored it out. Well, now, even though there are crazy parentheses and a lot of stuff going on right here, I can still ask that same question. What's my greatest common factor between these two? And it's x plus 2. So that's what I'm factoring out technically again, okay? But a nice and fun, easy way to say it is, what do I see double of and what's left when I take those away? And that gets me my answer, okay? But I wanted to make sure y'all actually saw and heard the math reasoning behind it, okay? That's called factoring by grouping. That will work for every single problem we've done so far. So if you're like, give me one way and one way only, that's your one way, okay? What about this next one here? Can I make my life easier? Okay, so I can't really, if I was setting it equal to 0 or equal to something like that, then possibly I could get away with that, but I get what you're saying. Let's factor out a -1. Which technically you are dividing by a -1, but we need to keep that there. There's a big difference between solving by factoring and just factoring, okay? Because if we were solving, remember I told you the -1 really doesn't mean anything, okay? But since we're factoring, it does mean something. It needs to stay there. Okay, now I have a leading coefficient of 1. Two numbers that multiply to get 16 but add to get 10. What'd you say? 8 and 2. Okay, so the -1 has to stay there when you are factoring. If you are solving, you don't need it. We don't need to do number 3. We've done 1,000 of those. But I will tell you this much. On number 3, our factors of 25 that get us 10 are 5 and 5. Don't write it as x plus 5 times x plus 5. Go ahead and write it as x plus 5 squared. So on your homework, it might ask you to factor by perfect square trinomials. Why? I don't know. Okay. They have this formula, and you don't need to write this down. That's called perfect square trinomial. They're saying, hey, if you see an equation like x squared plus 10x plus 25, and it fits this mold of a squared plus 2ab plus b squared, then all you have to do is factor like this. I'm sorry, in the process of figuring out if it fits this mold of this formula that I had to memorize, I would have already gotten this answer and I moved on, okay? So this is just another way that they have a formula that fits this. I wouldn't worry about it. Waste of time, okay? But I didn't want y'all, every single time I skip over it in my lessons and kids are like, hey, on the homework it says to factor by perfect square trinomial. What do I do? Factor, like you always do, okay? All right, try these 4. Remember, we are factoring and not solving.
She had called during 7 a.m. I get in trouble in here. But then,
Okay, factors of 16, -8, -8. What are they?
feel.
-4, -4. So I would just write x minus 4 squared.
I totally forgot the number 4 existed for that number.
You forgot what?
I totally forgot the number 4 existed for that.
Oh.
I don't know what it is.
You're like,
Yeah,
can't be factored.
my brain kept going to 2, and I'm like, it's not 2.
I can't figure it out.
The one that will mess with you is number 3.
I got that one.
It's always 6 and 5. That will always mess with you. Yeah.
So will it count us wrong? Because I know you probably won't, but do you think the state test will count us wrong if we put x minus 4 and then another x minus 4?
Here are
Because
my
I-
answers for every state question or question.
No
Every
idea.
state. I don't know.
Yeah.
Okay. I would hope that they would allow, because you have to consider you're taking the same test as the CP Algebra 2 kid is.
Yeah.
If they're going to be that picky, then that's on them. Okay.
I mean, that just, well, because, I mean, you can't swear it. I just my thought process was it's not technically factored, I guess.
You're wanting it to stay to.
Yeah, no,
Yeah.
it's just the.
Yeah, no, I would hope they would have multiple. I would hope, but I have no idea. Those people make a lot more money than I do, and I still don't know what they do. Okay, so yeah, number 3, the 6 and 5 will get you every time, and that's because you've got 2 and 3 as an option, and 6 and 1, and just for some reason it will mess you up, and I don't know why it does that, but it does. Okay, so we want 2 and 3 for this one because we need a positive, and we need them to add to get 5. Okay. Up here in the corner, 5 times 4. This is also another one that people tend to forget. The one that people tend to forget. Factors of 20, they get you 21. 20 and 1, okay? Everyone always forgets those because they're like, oh yeah, 1 times the number is a factor as well. So 20 and 1. So we split apart the middle. And we factor by grouping. So I can take out a 5x here. I'm left with x plus 4. I can take out a 1. I'm left with x plus 4. What do I see double? X plus 4. And what's left over is 5x plus 1. Okay. And on the test that y'all took, the last test you took, actually solving for 0 was the hardest part for y'all here. Okay. I already had the equation factored for you. And I said, tell me the zeros, and y'all all created some new math. I don't know what you made up, but you created something. Now, looking back, if we just set these equal to 0, we get -4 and -1/5, which is tomorrow, okay? So, don't let that be too difficult for you. Now, number 4, I am showing you this problem because you can still solve it the same way we've been doing every single problem. But there's a shortcut on the next slide, okay? So, what is missing on this problem? B. So, I could put 0x in there if I want to. If I was solving, I would have moved 49 over, divide by 25, take the square root, plus or minus 7/5, okay? But since I'm factoring, I can't do that. Now, one way of looking at it is, hey, I've already figured out if I set it equal to 0, I get x equals plus or minus 7/5. Then you can turn that into factors if you want to. Y'all can do whatever method you want to approach this, okay? So, if I multiply 25 times -49, yes, that's a massive number, okay? But once you find that massive number, which is what, -1,225? I didn't come up with that, I did in last class. I just remember that number. Oh, I wish I was that good. If I think about it though, I want 2 numbers that multiply to get that, but then add to get 0. So what does that tell you about the two numbers you're gonna find? They're the same, okay? And in order to figure out something that's the same, what a better way than just taking the square root of that number, okay? So if I take the square root of that number, I get 35. So I can split this apart. And I can factor by grouping. This is 100% the long way of doing this problem, but I'm showing you, you can do every single factoring problem the same way. So here I'm going to take out a 5x. I'm left with 5x plus 7. I'm going to take out a negative 7. I'm left with a 5x plus 7. So 5x plus 7 and 5x minus 7. When our answer plus or minus 7 fits. Okay? So if you did solve, let me write that out real quick. If you did solve it that way and go backwards and say, oh, I can write those as zeros, this is not how you would write your answers. It's still technically true, but we're at an honors level, okay? So we can bump that 5 over here by multiplying by 5. Same thing here to get our 5x plus 7 and 5x minus 7, okay? That's how we write our factors, okay? So, what's the shortcut you say? This is a minus sign. Another word for that is difference. Do what? Huh?
Because I'm a great student and you love me.
I heard that part. I didn't hear anything else you said before, so I'm going to stick with that part. Okay. So here's a minus sign. That means difference. Okay. And that's two things I can take the square root of. That is called difference of two squares. All right, so if you notice the minus sign in between, you notice that they are perfect squares, difference of two squares. All you have to do is take the square root of the first one, square root of the second one, add them together, subtract them together. So 25x squared is just 5x. Square root of 49 is just 7. Add them together, subtract them together. Saves you a whole lot of time. I don't even teach my CP kids that. That's too much. Okay? One way to factor, one way only is helpful. But if you can catch on to shortcuts, they are helpful. Okay? Whoops. Can I do difference of two squares with that? Okay, why are you shaking your head yes?
Because you can factor out a 3, and then you get 4x squared minus 9, and those are both perfect squares.
Okay, so sometimes, and all the time, you should ask yourself, is there a greatest common factor I can take out first? And when that's the case, then yes, you keep going from there. What about if I gave you, and so this one to finish it out, 2x plus 3 and 2x minus 3. So that's completely factored. What if I gave you a problem like that? Okay. I would get, hold on, let's amp it up a little bit. Can you still find difference of squares there? Yeah, okay. Well, what's the square root of x to the fourth? X squared, and the square root of 16. So x squared plus 4 and x squared minus 4. Am I done? No, why? Do I do it to both of them? Only the difference. So this one would stay the same. And this one would become x plus 2 and x minus 2. When they want you to factor completely, they mean it. Okay? They want you to take it down as far as it can go. Any questions on this? What would be my zeros here? What would be my 0 from this one? Negative 2? Positive 2? Positive negative what? Be careful. Oh, 2i. 2i. Good. So and that's the only difference from what we're doing today is the difference from tomorrow. If I subtract 4, I get plus or minus 2i. Okay. And then I would have x equals negative 2 and x equals 2. Okay. I just wanted to keep going on those problems. Keep the math flowing. Here we go. Do 4 more. Anyone supposed to take their picture? Yeah, go take your picture. Yeah, y'all could have stopped me.
Oh, I forgot.
Do what?
I forgot.
Oh.
Bye, Matt.
Where's the picture?
Were y'all atrium or were y'all the gym?
Which one?
Smile pretty. Cheese.
Oh, you go now.
Where?
You go to the stairs gym.
Okay, looks like I'm gonna follow those guys then.
I don't know if that's a good idea.
I don't know.
Because they're gonna go to the auditorium. You need to go to the.
They're going to the atrium. You need to go to the auditorium. Or
No,
not?
you
need to go to the
upstairs
upper
gym.
gym.
Yeah, I want a picture here.
See you guys in like a. I'll be in like a gray box with nothing, you know, drug
They're gonna ship him to Abu Dhabi.
I'm eating Colin. Hungry. All right, so with number 3, square root of 9x squared gets me 3x. And the square root of 16 gets me 4. And I add them together and I subtract them together. Okay. Remember, that's a lot like the complex conjugates. Remember when we were doing a plus bi times a minus bi? The middle term disappeared. Convenient. It did here as well. Okay. All right, and then up here, factors of 12. That get me -7. What are they? Okay, so -3x and -4x. And then I group. I can take out an x, I'm left with 2x minus 3. I can take out a 2, I'm still left, or a -2, I'm still left with 2x minus 3. I did 2x minus 3 twice, and x minus 2 was left over. Okay, so hopefully, if you were at a point of, I'm kind of iffy on factoring, now that you're to a different level, you're like, I got this now. If not, please let me know. Do not leave chapter 4 without knowing how to factor, okay? Because then when we do other chapters, and then when you go to pre-cal, it's expected. Yeah.
Does it matter which of the two numbers you factor out though, and which on number 2? Because I put them.
Are you saying,
Yeah.
did you switch those?
Yeah.
Yeah, that's fine. It doesn't matter. So if you had this flipped, that's fine.
There's no like specific order.
Any other questions on that? Just like it doesn't matter if you put 3x plus 4 or 3x minus 4. I always just say add them and subtract them. So that's just natural for me to put adding first and then subtracting. So you can flip flop them. Remember, math is, don't say anything mean. Math is, there's a word that says I can move.
The best subject in school.
Amen.
Math.
Math, not sorry. Multiplication is
Oh, well, you change it up.
commutative. Woo! Okay. When you go to the University of Tennessee one day,
Well, when? Okay.
they have parking passes, and there's non-commuter passes and there's commuter passes, which means you're commuting. Okay, you're moving, so multiplication and adding is commutative. So that can help you remember. And yes, it is the University of Tennessee. And if you say at Knoxville, I'll get really upset. Because I don't like that. Okay. You laugh? You want more examples?
I mean, not really, but I'm just saying I do think it's amusing, but not in a mean way. I'm not making fun of you, I'm laughing.
My sister goes to
I wasn't
UTC, so
laughing.
they call it UTK most of the time.
No, that's not right.
Well, too bad. They call it.
No, it's not right.